Hey guys, we're going to take a look today at solving systems of equations. There's a whole bunch of different ways that you can solve systems of equations. We're going to look at the two algebraic approaches, substitution and elimination. Now, each of these will work for any system of equations, but sometimes one is more easy to use than the other. The objective of each of them is, if we look at these equations, we have two equations in two different variables. The first couple of steps of both of these approaches get us an equation that's all in one variable. Then once we have that equation in one variable, we can solve it and then use that solution to find the other one. So let's start with substitution. With substitution, it's exactly what it sounds like. You're going to put one thing in place of something else, and that's how we're going to get an equation in one variable. So we start by solving one equation for one variable. It doesn't matter which equation, and it doesn't matter which variable. So pick the one that's easiest for you. Then once you have that variable all by itself, you'll have something like x equals 3x plus y. Or excuse me, x equals 3 plus y. You're going to sub that into the other equation in place of that variable. Then you've got an equation all in one variable. You can solve it and then use that solution to find the other solution. Sub it into the other equation and solve for the other variable. So let's start here. I've got 2x minus 3y equals 3 and x plus y equals 14. And I want to take one of those equations and solve it for one variable. Well, if I look at this second equation, it's going to be pretty easy to get x all by itself. So I'm going to take what x is equal to, I'm going to take x and get it all by itself. Actually, you know what? I'm going to solve for y. So I'll get y by itself. I'll subtract x from both sides. And I'll have y equals 14 minus x. Now, I'm going to take what y is equal to and put it in place of y in the other equation. So I'll have 2x minus 3 times, instead of y, I'm going to put 14 minus x, still equal to 3. Okay, now I'm going to have the equation that's all in x, and I'm going to solve it for x. So I'll start by distributing that negative 3. Don't lose sight of that. It is a negative 3 getting distributed. So negative 3 times 14 is going to be negative 42 minus negative 3 times x is negative 3x equals 3. Bring down that 2x in front. Okay, now we're going to combine our like terms, but keep in mind, this minus a negative becomes plus plus. So I have 5x minus 42 equals 3. I'll add 42 to both sides. And I've got 5x equals 45. Divide both sides by 5, and we have x equals 9. Now, once we have what x is equal to, we can use that and sub it in here to find what y is equal to. So y is equal to 14 minus, instead of x, 9, which means that y equals 5. Now your solution to a system of equations is an x-y pair. So we want to put these two together in an ordered pair. So our answer, instead of x equals 9 and y equals 5, we just say the ordered pair 9, 5. And there we go. Okay, let's take a look at another one. Okay, same thing, I've got two equations and two variables. I want to solve one of those equations for one variable. So I'm going to go after this first equation because I think getting that y by itself is going to be easiest. So I'll start by subtracting 5x from each side. And I'll bring that down here, and I'll have the opposite of y equals 17 minus 5x. Now this is the opposite of y. There's that negative sign in front, and I want y all by itself. So I'll divide both sides by negative 1. Left side's easy. Negatives cancel, y is all by itself. On the right side, remember to divide everything by that negative 1. So this positive 17 becomes a negative 17. This minus 5x becomes plus 5x. Okay, now we have y all by itself. We're going to take that and sub it into the other equation in place of y. So I'll have 3x plus 2 times, instead of y, negative 17 plus 5x equals 5. And now we've got an equation that's all x. We can solve this. So I'll start by distributing that 2, and I'll have 3x plus 2 times negative 17 is going to be negative 34, plus 2 times 5x is 10x. Combine your like terms. You got 3x and 10x, put those together, and you have 13x minus 34 equals 5. Add that 34 to both sides, and you have 13x equals 39. Divide both sides by 13, and you have x equals 3. Okay, now, that's half of our solution. We want to take what x is equal to and put it in place of x in that other equation. So we'll have y equals negative 17 plus 5 times 3. Okay, well, 5 times 3 is 15. So I've got negative 17 plus 15, which means that y equals negative 2. Now, instead of having our solution x equals 3 and y equals negative 2, we'll just write the ordered pair. 3, negative 2. And there we go. Okay, one more. Okay, we have 6x plus 3y equals 12, and 2x plus y equals 8. And I want to take one of those equations and solve for one of those variables. And it doesn't matter which equation, and it doesn't matter which variable. So pick the one that's easiest for you. For me, getting that y by itself in the second equation looks like the easiest task. So that's what I'm going to do. I'll subtract 2x from both sides, and that will give me y equals 8 minus 2x. Then I'll take what y is equal to and put it in place of y in that other equation. So now I have 6x plus 3 times, instead of y, 8 minus 2x. Still equal to 12. Now we've got an equation that's all in one variable. It's all x's, so we can solve that. We'll start by distributing that 3, and we'll have 6x plus 24 minus 6x equals 12. Okay, now we want to combine our like terms. I've got the 6x and the negative 6x, and if I put those together, I get 0. So they cancel. And what I have left is 24 equals 12. 24 doesn't equal 12. So I want to go back and check and see if I made a mistake. But there's no mistake in our work. Okay, we subtracted 2x from both sides, y equals 8 minus 2x. We sub that into the other equation, so 6x plus 3 times the quantity, 8 minus 2x. We distribute that 3. 3 times 8 is 24. 3 times minus 2x is minus 6x. 6x minus 6x is 0. There's no mistake here, and all of the variables cancel. So we look at the remaining equation, and it's false. All the variables cancel, remaining equation's false. This system of equations has no solution. Now, there may be times where you do a lot of work going through the whole problem and you find that that system of equations has no solution. That's not a waste of time, because finding that the system of equations has no solution is just as good as finding a numerical solution. Okay, this is solving equations with substitution. When we come back, we'll take a look at solving equations using elimination. Either one of these will work for any system of equations. The benefit of solving with substitution is it's pretty straightforward. There's no real tricks to it. It's just algebra. Okay, get a variable by itself, sub something in place of that variable, solve an equation. Sub that solution into the original equation and solve for the other variable. Okay, just remember that the solution to a system of equations is an XY ordered pair.